My dear students, in this video also I am going to solve some permutation problems in the topic permutations which are given in your textbook. The exercise problems in your textbook in the topic permutations, we are going to solve few more problems. The first problem is 3 men have 4 coats, 5 pants and 6 shirts. In how many ways can they wear them? 4 coats, 5 pants and 6 shirts to be worn by 3 men. In how many ways they can wear? See, total men are 3. 4 coats, 4 coats, 4 coats are where 4 coats are whereby 4 coats are wearing in 4p3 ways. 4 coats are wearing by 3 men in 4p3 ways. Similarly, 5 pants are wearing in 5p3 ways. 5 pants can be worn by 3 men in 5p3 ways, and 6 shirts are wearing by 3 men in 6p3 ways. 4 coats can be worn by 4p3 ways because 4 coats wearing by 3 men, 5 pants by 3 men, 6 shirts by wearing by 3 men. But the total number of ways are of wearing these 4 coats, 5 pants and 6 shirts are 4p3 into 5p3 into 6p3. That's all. You simplify this. 4p3 you know, 4 into 3 into 2. This is 24. And 5p3 is 5 into 4 into 3. 5 fourths are 20 into 3 60. And 6p3 6 into 5 into 4 because we have to reduce 3 numbers. From 6 we have to reduce 3 numbers 6, 5, 4. From 5 we have to reduce 3 numbers 5, 4, 3. From 4 we have to reduce 3 numbers 4, 3, 2. 4, 3, 2, 4, 3, 2 like that. So this is 120. So this is 24 into 7,200. See, this is 1,72,800 ways of wearing this. 1,70,000. After multiplying this 24 into 7,200, you will get 1,70,800. So 1,72,800 ways of wearing these items by 3 men. That's all about the problem. Okay? See, the next problem in your textbook, it is in your exercise problem number 5 in the textbook. But this question is, test consists of 10 multiple choice questions. A text question paper consisting of 10 multiple choice questions. In how many ways can the test be answered if the following 3 conditions? First condition, each question has 4 choices. There are 10 questions. First condition, there are 10 multiple choice questions. Total questions are 10 multiple choice questions. Each question has 4 choices. Each question has 4 choices. So 10 questions. First question has 4 choices, second question has 4 choices, fourth question, third question and so on. 10th question has also 10 questions. Therefore total ways of answering the test. Therefore total ways of answering the test is 4 power 10. 4 into 4 into 4 into 4 into 10 times there, because 10 questions there. Each question have 4 choices there. Therefore, 4 power 10 ways of answering. That is your first condition. Okay. Second one is 4 questions have 3 choices. 4 has 3 choices. And the remaining how many questions? 4 questions out of 10. 4 has 3 choices. Remaining 6 questions have 4 questions have 3 choices, and 6 questions have how many choices? 5 choices. Therefore, total ways are 4 questions have 3 choices. So, 4 questions. Each question has 3 choices. Therefore, you will get 4 questions. Each one have 3 choices. Each question have 3 choices. You will get 4 questions. The remaining 6 questions have 5 choices. 6 questions. 1, first, second, third, fourth, fifth, 6 questions have 5 choices. Therefore, the total ways are 3 power 4 into 5 power 6. 3 power 4 into, like 10 questions have 4 choices, we will get 4 power 10. Similarly, 4 questions have 3 choices, therefore 3 power 4 ways of answering. And remaining 6 questions have 5 choices. Each question have 5 choices, therefore 6 times of the 6 questions are there. So 5 into 5 into 5, 6 times of 5 power 6. The total ways are 3 power 4 into 5 power 6. That's all about the second subdivision. Third, I will solve now. Okay. Next question. Question number n has n plus 1 choices. See, there are 10 questions, multiple choice questions. Nth question has n plus 1 choices. Question number n. Suppose first question. First question has n plus 1 plus 1, 2 choices. Second question has 2 plus 1, n plus 1 rule. Nth question have n plus 1 choice. First question have 1 plus 1. First question have 1 plus 1 choice. Second question have n plus 1, 2 plus 1, 3 choices. Third question has 3 plus 1, 4 choices, because rule is n plus 1 choices. Fourth question has 4 plus 1, that is equal to 5 choices, and so on like that. 10th question like that. 10th question has 10 plus 1 choices, 11. So, the total number of ways of answering for the third condition. Now, the total ways of answering all the 10 questions in the rule. Nth question has n plus 1 choice. Using that rule, first question has 2 choices, second question has 3 choices, third question has 4 choices, and so on like that. 10th question has 10 plus 1, 11 choices. Therefore, total number of ways of answering. Therefore, total number of ways of answering. N question is n plus 1 choices. That condition is total ways of answering. Two into, 3 into, 4 into, 5 in first question, second question, third question, fifth question, etc. 10th question 11 choices. So 2 into 3 into 4 up to 11 is nothing but 11 factorial. If you multiply by 1, it's also 11 factorial. Same. Therefore 2 into 3 into 4 into 5 gives you nothing but 11 factorial. So that 1 into 2, 1, you need not write 1. If you write it 1, it's also 11 factorial only. Therefore, this is nothing but 11 factorial. So, if the n question has n% choices is the third condition, the total number of ways of answering 10 questions are 11 factorial ways. That's all about the problem. Okay? Now, next problem. You see the problem, 8 women and 6 men are standing in a line. Women 8 members and men 6 members are standing in a line. First condition, how many arrangements are possible if any individual can stand in any position? So that 8 women and 6 men can stand in any position. Totally there are 14 members. 8 women plus 6 men. 14 members can stand in any position. 14 members can stand in any position. Stand in 4 factorial, stand in any position. That means they are standing 14 factorial ways. That's all about the first question. 8 women, 6 men, they are stand in any position. Totally they are 14 members. They can occupy any position in the line. Totally they are 14. Therefore, the total ways are 14 factorial ways. That's all about the problem. Second one. "14 factorial ways." First question answer is 14 factorial ways. Second question. In how many permutations, arrangements and permutations are one and the same? If you say arrangement or otherwise permutation, will all 6 men be stand next to one another? See, 8 women standing in a position and 6 men stand in one unit. 6 men stand as one unit. Totally they are 8 women plus 6 men as one unit. 6 men. 8 women plus 1. 1 means 6 men. 6 men can stand together as a one unit. Therefore, we can consider this as 9 units. Okay. And these 6 men stand as one unit. Therefore, we can consider 8 plus 1 9 units. So 9 units can stand in 9 units, or 9 members can stand in 9 factorial ways. And these 6 men can stand together in 6 factorial ways. But the 6 men stand together in 6 factorial ways. They themselves arranged in 6 factorial ways. Men themselves. Therefore, total ways are 9 factorial into 6 factorial. Therefore, the second condition, the total ways of arrangements, the ways of arrangements are 9 factorial into 6 factorial. That's all about the second condition. Okay, and we will see the third condition now. Okay. Now, the third one is, in how many arrangements will no 2 men stand together? 6 men. In the third case, they are not standing together. No 2 men stand together. That means they are each and every man, there is a gap. See, totally, 8 women. 8 women. 8 women. 2, 3, 4, 5, 6, 7, 8 women are there. In each and every woman there is a gap because no two men stand together. Therefore 1, 2, 3, 4, 5, 6, 7, 8, 9 places are there. The intermediate in between the women, 8 women, there are 9 places are there. In these 9 places, 6 men should be arranged. See, the 8 women are standing. 8 women are stand in 8 factorial ways. 8 women are standing in 8 factorial ways. These 8 places, 8 women can be substituted in 8 factorial ways. Inducted. 8 places, the 8 women are inducted in 8 factorial ways. The remaining, the 9 places, there are 9 empty places are there for 6 men. There are 9 places, 9 gaps or otherwise 9 gaps. There are 9 places for 6 men. In there are 9 places. There are 9 places. There are 9 places for 6 men. So these 6 men in array 6 men are stand in 9 places. The 6 men are stand in 9p6 ways. So 6 places, 9 places, 6 men should be stand in 9p6 ways. There are 9 places for 6 men. Therefore, they are arranged. They are standing in. Therefore, they are standing. They are standing in 9p6 ways. Therefore, total ways for the third condition. Therefore, the total ways of arrangements are. Total ways of arrangements are 8 women in 8 factorial ways and 6 men in 9 places is 9p6 ways. Therefore, total ways are 8 factorial into 9p6 ways. That's all about the third condition. So, thereby I conclude my video and we will solve few more problems in our next video. Okay? Thank you.